Welcome to part 3 of our simultaneous equations lessons. The one we're going to look at is a much more standard question. When you think about what you will see in an exam, it is much more likely the equations will be laid out like this, rather than in the form of a straight line. But it's important we understand where the theory behind this comes from. You are still actually solving for the point of intersection between these two equations. But our learning intention for this section is going to be able to solve a system of equations with a matching coefficient. Now, we use matching in a very specific way for simultaneous equations. We mean it for the numerical part, the number part of the variable. And unlike in a lot of areas of maths, we are going to ignore that sign in front of it. We don't care whether that number is positive or negative. We just want it to have the same number there. Hopefully you can look at that and you can see which out of x and y has the matching coefficient. So we have x or y. Our first question, it hasn't changed. X, both 4s, so we'll be able to get rid of that. Y, we have a 5 and a 3, not going to be able to get rid of that. So we're now focusing in on those x's. We want them to disappear. So we have to look at the sign, and this is our second question from before. Same signs. One's positive, one's negative, so our answer to that is no. And what do we do when they are not the same? We add. Adding these two equations, we set it up like the chimney sum. It's a much easier way to visualise it. You don't have to do it as a chimney sum, but I find that looking at things in the vertical columns helps me really focus in on what I'm doing at each step, because it is a bit confusing with your positives and your negatives. So we have 5y plus 3y gives us 8y. We have 4x plus minus 4x. That's going to give us 0. We're going to have nothing there. And we have 14 plus 2, so it's going to equal 16. Hopefully you can see where this is going. We have 8y equals 16 because the 0 disappears, and then we have y equals 2. Halfway there, second step, we have to substitute in. And again, we can pick whether we want to substitute into the first or the second. Personally, I go for the one that doesn't have the negative. It means I don't have to deal with quite as many variables and make sure I'm getting my negatives the right way around. So we're going to go for 5y plus 4x equals 14. Y is equal to 2, so we've got 5 times 2 is 10 plus 4x equals 14. And then we solve. So that 10 is going to go to the other side. It's going to become negative. So we're going to have 4x equals 14, take away 10. We're going to have 4x equals 4. Last step we have to think about. X equals 1. We're dividing through by that 4. So if you've just been asked to solve, you've been asked for x, you've been asked for y. If you've been asked for point of intersection, you need to turn that into a coordinate. But as it is acceptable to leave it with y equals 2, x equals 1. We'll be looking at other examples where you're going to have to write sentences at the end to make sure you're clear about what you mean. But that is solving a system of equations when you have a matching coefficient.